Hello, and welcome to our ISC project poster presentation about multi-level scheduling in high-performance computers, or MLS for short. This project is about the importance of dynamic scheduling and load balancing for expressing and exploiting parallelism at multiple levels in the HPC stack. The focus here is on parallel programming for the purpose of efficient exploitation of the available hardware parallelism during the execution, with the ultimate goal of performance optimization of both applications and systems. The project is funded by the Swiss National Science Foundation and is conducted by the HPC group at the University of Basel, Switzerland. Let's talk about multi-level parallelism and why is it challenging. The idea here is that for every level of hardware parallelism on the x-axis, from hardware instructions to nodes to global sites, we have a corresponding match on the y-axis in terms of software parallelism. And a user typically sees a single process on the y-axis running on a single node represented on the x-axis. This is where parallel computing intersects with sequential or even desktop computing in terms of hardware and software. Below this tuple node process, the parallelism is invisible and at much lower levels, and above it, it is more visible and at higher levels, both in hardware and software. In HPC, software parallelism is exposed inside applications, then it is expressed through the programming languages, and finally, hardware parallelism can be exploited. This is a complex and often overlapping multi-step process as shown on this slide. And the greatest challenge here is how to expose, express, and exploit this multi-level software-hardware parallelism to improve performance in the complex and rich and constantly evolving two-dimensional hardware-software parallelism space. The multi-level parallelism challenge is also challenging in terms of scheduling and load balancing of the workload. The current state of the art and current state of the practice in scheduling and load balancing is that resources are allocated to jobs by a batch scheduler independent of whether the application would perform well on those allocated resources versus others. This is called BLS, batch level scheduling. Application processes are scheduled and load balanced independent of the resources that were allocated by a batch level scheduler, and often also independent of thread level schedulers if the allocated resources consist of multi-core nodes. Application threads in turn are also scheduled and load balanced independently of any of the previous decisions above. So due to the disjoint operation between these scheduling levels, poor decisions at higher levels trickle down and limit any performance optimization efforts at lower levels. We, the HPC group at the University of Basel, are addressing this problem and are proposing a solution through which we bridge existing state-of-the-art scheduling algorithms at batch application and thread levels. We enable cooperation of scheduling between the disconnected layers in the scheduling stack and target to minimize idle times while maximizing resource utilization and improving application performance. And all of this is to better express and exploit the multi-level parallelism. This is an overview of all the achievements we have so far in the MLS project. Several achievements are at individual levels. For instance, at application level scheduling, we have result 2. At thread level scheduling, we have result 5. At application and thread level scheduling independently, we have result number 4. Or we also have, more importantly, bridged pairs of levels. Application level scheduling and thread level scheduling have been bridged, and we have results number 3 and 6, whereas batch level scheduling and application level scheduling have been bridged in one of the first results of this project, result number 1. We are currently working on the first BLS, ALS, TLS prototype. Stay tuned for ISC June 2021. For details about these achievements, we encourage you to see the poster, visit the website, or simply contact us. For more fruitful live discussions, you are invited to attend the face-to-face presentation on June 23rd at 16:30 Central European Standard Time. Thank you for your attention.